Hi, everybody. Problem 201 from the 2017, the official guide for GMAT review. It's published by Wiley. It's a green book. It's all you need to master the GMAT. All right, so let's look at this problem. A sequence of numbers, A1, A2, A3, is defined as follows. A1 is 3, A2 is 5, and every term in the sequence after A2 is the product of all terms in the sequence preceding it. Sort of sounds like a factorial, actually, doesn't it? For example, A3 is the product of A1 and 2, and A4 is the product of A1, A2, and A3. If AN, which means the nth term in the sequence, is equal to T, and in this case n is greater than 2, so it's a term beyond the second term, what is the value of AN plus 2 in terms of T? So that's a sequence problem. And let's write down some of the givens here. They say that AN is equal to T. And also here, that's N is greater than 2. So how does this work? Well, we're looking, what is the value of AN plus 2? Okay, and we're given AN. Well, let's draw sort of a table, a progressive table. If you have AN here, the next term is AN plus 1. The next term is AN plus 2, which is what we're looking for, isn't it? So, if AN is equal to T, AN plus 1 is equal to, now let's count, the way this works, right, is, let me show you something. Okay, so if this is AN plus 2 over here, the term preceding it is AN plus 1. The term preceding that is AN. The term preceding that is AN minus 1. Basically, as you go up, you add 1 to the subscript. And so, conversely, if you go down, you're taking away 1. So this is N minus 2, etc. Dot, 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 dot. And then also here, dot, 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 dot. So, the reason I say that is if we come back here, AN is equal to that. Let's look at the constituent parts of this. Well, it said here, if you read over here, it said that every term in the sequence after A2 is the product of all terms in the sequence preceding it. So this one is equal to A, it's the product of all the terms that came before. So it's the product of, the term before is AN times AN minus 1 times AN minus 2, dot, 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 dot. And actually this, it's called T from the givens over here. But it can also be written as the product of all its preceding terms. So this could be the preceding, the term right before this one is AN minus 1. The preceding term is AN minus 2, AN minus 3, dot, dot, dot. Okay. And then here, the one before that's AN plus 1. That's how these sequence problems look. This is etc. And the reason these dot dot dots, we don't know how far back it goes, right? T could be, I mean, see it says n is greater than 2. I mean, it could be 100, in which case there's 99 or 100 terms there. So, but let's look at something. Remember that this whole product, going back all the way, is called AN right here. So look at this. This is the same thing as the thing above, isn't it? Look. It's AN minus 1, N minus 2, N minus 3, dot, 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 dot. N minus 1, N minus 2, N minus 3, dot, dot, dot. So these things are equivalent. And another word for this whole group here going all the way back. And this whole group are the same. And they're both called, let's get another color here. They're both called, I wrote it here, but you can't see it. These things are both called AN, right? Right? And actually AN is equal to T, so, which is equal to T. And this AN here is also equal to T. So actually, it's getting crowded, but I'll go over here. This part is T, and this part is T. And then if we look at AN plus 2, which is the thing we're looking for, it's comprised of AN, which is again T. It's comprised of this thing, n minus 1, n minus 2, etc., which we said was also T. And look, we just, here, T times T is T squared. We just showed that T squared is the same as AN plus 1. So AN plus 1 here is T squared. So AN plus 2, which is what we're looking for, is the product of all these things. T squared times T times T. All right, and these have little ones here. We don't write it, but so anyhow, you add up. Either you can just see that right away, or you add up all these powers. 1, 2 plus 2 is 4. All right, so the product here of all these things is that T. Go ahead and do this out yourself. If you do it yourself, you'll see that it'll be pretty straightforward. It's a little sloppy here, but it's about each sequence being built has building blocks that are similar, and you can relabel them T. It's really a practice in relabeling. All right, until next time.